This is round 11 of Random LeetCode, under an hour. Let's get started. All right. Start the timer. Okay. The special square with mirrors on each of the four walls. Sure. Except for the southwest corner. Southwest. It's right here. There are receptors on each of the remaining corners. So 0, 1, 2. Yep. 0, 1, 2. Square room has walls of length P. And a laser ray from the southwest corner first meets the east wall at a distance Q from the zeroth receptor. Okay, so Q is the height of the triangle. Sure. Given to us just P and Q, return the number of the receptor that the ray meets first. Interesting. Test cases are guaranteed so the ray will meet a receptor eventually. That's interesting. So, given what I know about physics, right? The angle of reflection is always equal. So this angle is always equal to this angle. So what does that really mean? In terms of, oh wow, I do not remember trigonometry. Well, I can get this angle right here because I have P and Q as input. I get this angle, so I have angle side. I don't think that's a thing. It's square though, so I have side, angle, side. Yeah, I have side, angle, side, so I can calculate um, these two angles, or this, yeah, these two angles. Okay, so let's say I get this angle. Trigonometry, god dang. Side, angle, side. 90 degrees, and then Q. Right? So let's say I get this angle, then I know this angle. Whew. P of 2, Q of 1. How do they even do it? That's interesting. Wow. This just seems like physics. What about this is computer science? Anyway, so let's say it reflects here, 30 degrees. Say this is like 60, 60 here. Go back. What does that tell me? I know this is going to be, the length is P, right? So this is going to be P minus Q right here. And I know this angle is the same as this angle. And I know this is 90, and I know this is P. So using that, can I determine if it hits okay, so what I'm thinking is, ignore the trigonometry for a second. We'll determine if ray hits a sensor. If it does, return sensor. Else, find new. So essentially using the P, so essentially just like how this is the P minus Q and then this is P, essentially I just want to find the new angles and somehow recursively put that into the method again so that it just continues the same trigonometry calculation. Yeah, this definitely seems like recursion to me. But how do I detect if... Okay, I can pretty easily say it will hit a sensor if q divided, or p divided by q is equal to 2, right? So put that down. If p divided by q equal to 2, I guess the integer, oh no. Return, oh, how do I forget the side, or the actual sensor I hit? Okay, let's assume there's some count going on. Turn count, or iterate through sides to get sensor number. Because essentially, on the first pass, you're trying to hit 2, and if it's below half, then it'll hit the top wall, and you'll try to hit the southwest corner, which won't work. Then here, here, here. Oh my god. This is confusing. But anyway, I think you can, based off the P and Q values, I think you can determine which sensor, but it's kind of tough. Okay, well, anyway, otherwise, else. Or I should say else. If P are they integers? If they're 2 integers, that makes it a lot better. Just for my own head or my own sake. But anyway, so if P constraints for Q is less than or equal to P less than or equal to 1. Okay, so Q can be 2. Oh, that would also hit a receptor. And 0 would also hit a receptor. Huh. Interesting. So this is false. Wait, okay. Else if P is equal to Q. Else if P is equal to 0. Or Q is equal to 0. I should be going based off Q, so Q is equal to P. Q is equal to P over 2. Okay, so these are the conditions, the 3 scenarios where it's going to hit some kind of sensor, right? So the first scenario is if it bounces and it goes straight to P, so it's going straight across the diagonal, it's going to hit 1, right? Let's pretend like recursion doesn't exist and say, okay, return 1. If Q is equal to 0, then we're hitting this one, so we're returning 0. Sure. And if it's halfway through, then we're bouncing, we're hitting 2. Return 2. It's a perfect bounce. Okay, these are the perfect bounces. Now, the important part is here in this else statement. Just think here. Okay. Had to turn it to disturb. Anyway. Else. How do I figure out this bouncing thing? Well, let's say I would draw it out, but whatever. So let's say let's say this is 3, right? So 0, or the length of P is 3. If is equal to 0, then that would return, yeah. If Q is equal to 0, then we return 0, that's fine. If Q is equal to 3, then we return 1, just fine. and it's never going to be equal to 1.5. So if it's 1 or 2 is the question. And that's perfectly around the halfway point, so it's obviously dependent. So we say else if p minus q is greater than p over 2, else. Okay, so let's write some more comments. P minus q is greater than p over 2. That means p minus q, that means q is very small. So we're going to hit the top shelf. Hit the top. I should really say, well, I want to find a better way instead of saying top, but whatever, let's see. It's hitting the side on the right. Hits the side on the right of main contact side. So hits the side on the right of this if q is small, right? Otherwise, it hits the side on the across or opposite side, opposite. Is it the main contact side, right? So it hit here. If q was p minus q was less than, it can be equal to because of this, but if it was less than p over 2, p minus q is less than p over 2, that means q is large, which means, oh, would that also bounce here? Would it ever bounce here? No, that doesn't make sense. Wait, let's go here. So let's say it goes here. Oh, it would, yeah. Wait. May have missed it. I may have done this. I might have switched them around. If it hits up top, then it should hit the top first. If it hits on the bottom, it's not going to make it all the way far, so it's going to hit the opposite side. So p minus q, so this section is bigger than half, so it's right here, right? So if we hit the side here, let's say, where is that going to hit? It's going to hit opposite. Let's just switch this to less than then. Okay, there we go. I think that works. Anyway, next the usual question. Now, how do I recursively do this? Return mirror reflection. Now, how do I format this correctly? I think I can just use, I think I just put it in. So I can say, so imagine it'll blah, blah, blah. We're doing top side, right? So let's say it hits here and then goes here. Now I want to input mirror reflection for this point right here. So say originating from this beam. Yeah, originating from this beam. Where does it go? Bang. So my initial thought is, so obviously we can't originate in the middle of the side, right? That the whole premise of the problem is that you can't do that. So what if you make this point right here the southwest corner of a new square? So let's say I make P this differential, right? And that means that it would simulate the problem as if this is a square. I hope we can kind of draw that out, right? And then it'll say, okay, does it hit this point? If it does, it would return. See, that's the problem, because if it hits here, it would return one. If I'm thinking correctly. yeah, it would return 1 when in actuality it would just it might hit 0 depending on the size of the square. Oof, that's tough. I like the drawing smaller squares idea, but I don't know how to make it work. I'm close, I can feel it, but yeah, this recursion wouldn't work because let's say it hits here, the southwest coordinate isn't accounted for in the original square. So I have to somehow get the recursions to remember properties about the original square. It's interesting. Can I use a number somehow? Because it is integers. So this is 3, right? So let's say we hit a Q of 2. So right here. Then I know it bounds at a 1 away from 1. And then it bounce right here. 1 away from this guy. I'm gonna get trapped. So it's guaranteed to ray. Okay, let's try 3, 1, I guess. So 3, 1 is here. So it's gonna bounce here. It's gonna bounce here. Oh. Okay, so I think the fact that the ray will meet the receptor eventually means that it can't be this. Wait, no, it can't be this. Tentatively, because if it hits here and it goes here, then it's always gonna be bouncing the rectangle. Okay, so make this greater than again. So over here, and then tentatively this will be impossible. Impossible. And we're gonna return none, just in case. I want to know if that ever goes there. Okay, so let's say it hits the side opposite the main contact side. So it goes here, right? Well then, it will either hit 1 or 2, depending on the length. This problem is I'm not seeing any recursion then, which is a good thing, I believe. But I also believe I'm missing something. I'm very skeptical of this, but I will continue as if I didn't hear that. So for this problem, right, Q is 1. So it's going to hit here, and it's going to go 1 up again. It's going to go 1 up again, and it'll go here. I'll hit 1. So essentially the Q will be, it'll travel Q distance every time it hits a wall. Because over P it travels Q height, so and the reflection angle are equal, so it's always going to travel that same height since the distance doesn't change between sides. Thus, see, my problem with this is this problem doesn't require the room be square. Maybe the p over 2 does, actually. Anyway, I'm going to continue. I'm going to forget about that for now and then deal with that if I get an error with this card methodology. So what I'm saying right now is, okay, so p minus q is greater than p over 2. Nice. Right, p minus q, this is greater than p over 2. Right. So take q, and I say, well, if, or I would say q divided by p, right? P divided by q is the number of times it will bounce. If p divided by q is not a whole number, I'm going to tentatively say that's impossible. Very wishy-washy solution right now, but we'll see. Anyway, so if p divided by q is equal to 3, or not equal to 3, I meant to say if it's odd, mod 2 is equal to 0. That's if it's even, else. Right, so if it bounces, so right here I say, I'm going to base off this example pretty much. So 3 divided by 1 is 3. 3 divided by 2, or 3 mod 2 is 1. So it's odd. And which number does it hit? It bounces here, and it bounces there. It hits the odd one. And if it was 4 by 4, right, 4 divided by, or 4, 2, wait, let's do 6. 6, 2, right, so 6 is the side, and 2 is the length. That would still result in 3. Let's do 8, 2, right? P is 8, Q is 2. It would go 1, 1, 2, 3, 4, 5, 6, 7, 8. Yep. So if Q is equal to 0, then we return 2. Else, we return 1. This has to be this is too simple, in my opinion. I'm missing something. But hopefully it's that easy and I don't have to worry about this again. Oh. Oops. Wonderful. I'm sure this is going to fail. Yep, okay. Null. Huh. Well, let's use, 3, 2. I thought about this. Huh, I thought that was impossible. Okay. Well, there it is. That has me questioning my assumption that p divided by q will always be an integer. Like 7 and 3. Right, let's say it's p is 7, q is 3, so it'd hit right here. Then it'd go up and hit like around 6. And then it would go up and it'd hit here, just miss 1 by a hair. And it would bounce around. I think it might hit 0 then, actually. Let me try that. 7, 3. I just want to see what the result is. Oh, interesting. Wait, it says 1. Huh. This seems like a fluke. But I will not question it for now. I think I accidentally got it, if I'm being honest. But, well, I won't look a gift horse in the mouth. Okay, 3, 2, right? So, dealing with the square. say here, it's 3, and you hit at 2, so you hit it right here. So it travels 2 up, and it tries to travel 1 up. It can't, so it hits here. Travels 1 up this and then travels 1 up in this direction. Then travels again. It should hit 0. Oh, look at that. Okay. So what I'm learning is it's really just a amount of p divided by q. Or rather, p divided by q, if it's mod, if p divided by q is not wholly divisible, then it'll bounce around for a little bit and come back and converge somewhere. Okay. So I think I'm going to delete all of this. Or at least delete this portion. But let me try to write out an alternative while I'm doing it. So else, right? So if it's not clean hit, then my options are either here-ish or here-ish, right? So what do I want to do? I want to figure out which side it will bounce, right? So it's gonna be bouncing either it'll bounce like this and back, right? If it's this side, it'll hit here, here, here. Wait, actually that's not true. Yeah, I'm gonna think of it in terms of q, like the height, right? So p minus q is the distance that has been traveled, and we know that's greater than 0. So p minus q. Right. Now my goal is to find out where does it next converge. So am I looking for factor? Right. So 3. Let's think of 3 and 2. Right. 3 divided by 2 does not result in one of these. It's not equal, half, or 0. But if you double it, so 6 divided by 2, it does converge. So somewhere on the way back down, or converge, I mean a whole number. It is a whole number. So somewhere on the way back down, it hits it. So up, so 3, blah, blah. So it'll hit 2. Right. There's 1 here. And then so essentially if it's a whole number or not. When do they converge, right? So if I double 3, then it converges. Same for 7, right? If I double 7, 14 and 3, it doesn't converge. And then I add another 7, so 21. 21 and 3 does converge. So 7, so it'll go up and down 7 times, and then so let's think, right? Once, twice, thrice, 4, 5, 6, 7. So it's either 2 or 1. How do I know which one it is? I'm going to say, I'm going wild and guess here, if it's less than half, because it just makes sense in my head. If it's less than half, it'll hit one side, and if it's more than half, it'll hit another side. So if I'll say 7 and 5 right now, right? I'll add a case. Oh shoot. And I'll say that if I add 7 and 5, then it will be in sync. 7 divided by 5, it'd be 35. So greatest common or least common multiple, right? 1, 2, 3, and sorry, 1, 2, 3, 4, 5, 6. Wait, 1, so 7, 14, 21, 28, 35. And since 5 is greater than 7, I'm going to say what this hit. 7, 3 hit 1. So this is going to hit 2. Let's see it. Right. Oh, it does hit 1 again. That's interesting. I wonder why. I'm close though. So if I go 1, 2, 3. So find the least common multiple of P and Q. And if that's an odd number, it will hit 1 or 2. How do I determine which side though? I still can't get over it. Okay, let's think. The side depends on I think it depends on the Q, whether that's even or odd or something like that. So let's think this is 7. Right, this is 7, and we're hitting 1, 2, 3, 4, 5, 6. 7, 8. 9, 10, 11, 12, 13, 14, 15, or 13, 14. So it hit 0. I think so. I think I use bigger numbers. Let's say 15. And then use 2 and 3. Okay. Let's see. No, I want an odd and even number that both converge on the same. So 6, 2 and 3. Yeah. Let's do 6 for 2 and 3. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So it's P divided by Q, whether that's odd or even. So literally this. Okay, so this is for left or well, dang it, already here. Left or right sensor on the respective sides. And then this is going to determine what side. So how do we determine the side is top or bottom, right? How do we determine which one it is? That's again divide or find the least common multiple. And is that an odd or an even, right? So I don't even need any of this, if I'm being honest. necessary. What I really need is just a for loop that says for count, or let's say size is equal to 0 for I, or let's just store that LCM actually. No, let's store size. Anyway, while changing my mind back and forth, but I have a reason, I promise. So while LCM is less than P, or I'll just say not equal to P. Oh, the end is less than P. Because if it's greater than P, then it's not going to converge, so. Anyway. While LCM is less than P, LCM plus equals P. Wait. While LCM mod Q, I should start as P. Well, LCM mod Q is not equal to 0, right? We just multiply it again. Or we add it again. So 7, 14, 21. Yeah, that's what they're doing. And then finally, that'll finish. And we'll get the LCM. I'll say, okay, if, right here, I'll say if LCM divided by Q mod 2 is equal to 0, right? Else? Okay. So if it's an even number, right, then it'd be, let's say 4 and 2, or 2 and 8, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, then it's gonna hit the bottom side. Wait. The LCM of 2 and 8 is 8. So how would that hit the bottom side? I might be tripping, but LCM 8 divided by 4 mod 2 is even, so it'd be even. It's like 5 and 35. So 1, 2, 3, 4, 5, 10, 15, or wait, it's 7, 5 and 7. So 5, 1, 2, 3, or 7 and 3, 3, 6, 2, 5, 8. So 5, 1, 4, 7. So yes, it travels 3 times because an LCM is 21, and 21 divided by 3. Oh no, I want to know the number of times P is added. Right? So traveled is equal to 1, because we're traveling up 1. And if the LCM doesn't work, say traveled plus equals 1. So we traveled one more side on the square. right? Okay. So now if you do 8 divided by 2, right? The traveled mod 2, traveled would be 1, and thus it would hit this side, 1 or 2. Is equal to 1, else it would hit 1 or 2, 0, or keep going. Well, okay, and then we go here. Let's copy paste this code. So I know it's gonna be 1 or 2, so let me just think through this quickly before I let it run. So if p divided by q, right, is mod 2 is equal to 0. So essentially p divided by q, 7 and 3, that's not gonna be a whole number. This doesn't seem right. What am I looking for? I'm looking for, let's do 6, 3, and 2, because I forgot what I was saying. 1, 2, 3, 2. Oh, I see what you mean. You want to do LCM divided by Q. So basically, how many bounces does it take to get to the LCM? If it's an even number, right? 1, 2, it's gonna hit 2. If it's an odd number, 1, 2, 3, it's gonna hit 1. Now, same thing. LCM divided by Q mod 2 equal to 0. So 1, sorry, 1, 2, 3, 4, 5. So if it's odd, equal to 1, then we return 0. If it's not, so let's say it bounced exactly on this corner, well, will it just return back to 1? I'm not very sure. Does that make sense physics-wise? If you hit a corner dead on, does it just go right across the diagonal? I'm gonna assume it does. If it's wrong, the examples will correct me. Seems right to me. Oh, look at that. Okay, wait, no, that was expected. The question is, I could probably engineer an example, but let's leave it up to the judges. Boom, there we go. And it's done. 43 minutes. Great work.